No problem. Dr. Rukmani Madam, Namaskara.
Namaskara, sir.
How are you?
All good, sir.
Thanks for joining.
Thank you. Same to you.
Another 5-10 minutes, madam.
Okay, no
Students are
problem, sir.
joining.
Yes, sir. Fine.
Rukmani madam, shall we start?
Yes, sir. We can start.
Good evening. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಇವತ್ತು ಡಾಕ್ಟರ್ ರುಕ್ಮಿಣಿ ಮೇಡಮ್ ಅವರು ಬೇಸಿಕ್ಸ್ ಆಫ್ ನ್ಯಾನೋ ಟೆಕ್ನಾಲಜಿ ಅಂಡ್ ಇಟ್ಸ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಬಗ್ಗೆ ತಮ್ಮ ಉಪನ್ಯಾಸವನ್ನ ಕೊಡ್ತಾರೆ. ಅದಕ್ಕೆ ಮೊದಲು ಲೆಟ್ ಮಿ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಡಾಕ್ಟರ್ ರುಕ್ಮಿಣಿ ಮೀನಂಬಲ್ ಟು ಆಲ್ ಆಫ್ ಯು. Madam is currently working as faculty under the Department of Science and Technology funded INSPIRE project at Department of Clinical Psychopharmacology and Neurotoxicology at NIMHANS. She has earned her BTech in Biotechnology and Biochemical Engineering from Kerala University. Scientific conclave as of date, and she has obtained Best Oral Presentation Award from the abstract titled Synthesis, Structural Elucidation, Optical, Magnetic and In Vitro Evaluation of Lanthanide Phosphate Crystals as Bioprobes in the 3rd International Conference on Material Sciences and Nanomaterials held at the University of Oxford in the United Kingdom. She has also been the recipient of Travel Fellowship Award sponsored by Center for Cooperation in Science and Technology among Developing Societies to attend 3rd International Conference on Material Sciences and Nanomaterials. And she is also the recipient of Innovation in Science Pursuit for Inspired Research, that's INSPIRE Fellow. Faculty, she is a faculty awarded in 2018 for the project titled Engineered Angiopep Conjugated Gadolinium Phosphate Nanoparticles for Image Guided Brain Therapy. And she is also a Lady Tata Memorial Trust awardee for Scientific Research Fellowship. With this brief background, I request Madam to deliver her lecture on basics of nanotechnology and its applications. For Madam, we have with us our Honorable Chairman Professor S. Ayappan, who was the Director General of ICR and Secretary Department of Agriculture Research and Education, and he is the present Chancellor of Central Agricultural University, Impal. Welcome to you, sir, for this talk, and I also welcome all the student friends. I purposefully kept this nanotechnology for this talk because nanotechnology is the sunrise sector which will be affecting each and every field. You take chemistry, physics, biology, anything, nanotechnology will be required. So Madam will be speaking on the applications of nanotechnology in this particular talk. Over to you, Madam.
Thank you, Dr. Ramesh, for the introduction. And now let's get into the talk. Good afternoon, all young aspiring researchers, meritorious pre-university students. Welcome to KSTA webinar on basics of nanotechnology and its application. Are the slides visible, sir?
Madam?
Are the slides visible?
Yes,
sir?
madam. Yes, madam.
Slides are visible.
Okay. Yeah.
The first slide is visible, madam.
Okay. Yeah. Now. Yeah. Thank you for the introduction, Dr. Ramesh. I am Dr. Rugmani Meenambal, working as faculty under DST Inspire funding at NIMHANS, Bengaluru. Before we start the nanotechnology exploration, I have a question for you. What do you see in this image? You all use mobile phones, right? So what do you see in this image? A mobile phone charging. I'm sure you all have waited long for your battery to get charged, right? The average mobile phone charging times vary from 2 hours to 4 hours. Now, would you be happy if you get it charged in 1 hour? Now, what do you think if it gets charged in 10 minutes? Do you really think it's possible for your mobile phone to get charged in less than a minute? Yes, it is possible. Recently, scientists from Israel have created batteries that takes only 30 seconds to recharge a battery using a field called nanotechnology. Now let's start the basics of nanotechnology. What you mean when you really say nano? A nanometer is 1 billionth of a meter, that is 10 power minus 9 meter. This is a study which manipulates the basics of various materials and devices at nano scale. And you all are studying basics of chemistry, physics, biology. So this is an interdisciplinary field where you merge more than one field to understand the applications. Basically, you need to know the fundamentals in basic sciences and the application in technology at nanoscale. Now we'll all have a question in mind. How big is a nanometer? So the answer to this question is in this slide. As you can see, here is a scale which shows the size of different objects. Towards the left hand and right hand is 1 meter. You know the average size of a human being is approximately 1.5 to 1.7 meters, right? Now moving towards left, you can see the normal calculators we use, mobile phone we use. They are approximately 12 to 15 centimeters. Now, smaller objects like insects that we see, ants are 2 millimeter in size. And how about a human hair strand? When you visualize it using a electron microscope, you get the size range of about 100 microns. You all have studied biology in your classes where you have studied about bacteria. And E. coli, the size of a typical E. coli is around 2 micrometers. Now, how about the virus that causes common cold? The rhinovirus is approximately 30 nanometer in width. That is 10,000 times smaller than your hair, a strand of human hair. Now at the leftmost, you can see DNA molecule. That is approximately 2 nanometer in width. That is 1 billion times smaller than the height of a human being. Basically, we consider any object as nano-sized object if it falls under 1 nanometer to 100 nanometer. This is an image of a scale or a ruler. A ruler is incremented in units of centimeter, right? Now, what is the smallest division in it? 1 millimeter. This is for you to understand how small is a nanometer. So the smallest division is 1 millimeter. A nanometer is million times smaller than the smallest measurement you can see on a ruler. So it is not visible with our eyes. Now let's understand some of the historical aspects in the development of nanotechnology. For the first time, humans have been investigating nano-sized existence, and the concept of nanotechnology is attributed to the physician and Nobel laureate Sir Richard Feynman. In 1959, in his talk titled "There is a Plenty of Room at the Bottom," he introduced the concept of visualizing and manipulating things in nanoscale or smaller scale. And he explained how this will revolutionize different industries and how it will provide answers to fundamental questions. He also spoke about storage of information in smaller size, miniaturizing the computer. If you remember the old computers, big desktops that are white in size, now you see the recent laptops, how small they are. So that is how mini computers are miniaturized using various technologies. The forward vision to medical field is attributed to Sir Albert Hibs. He introduced the concept of swallowing the surgeon, where the diagnosis by tiny robots is possible. These tiny robots are able to access the interior of the body, identify the problem, and repair it. Further, in 1974, the nanotechnology as a term was introduced by Professor Norio Tanguchi. And one more thing I want to tell you, we cannot visualize nanoparticles. We cannot visualize by normal microscopes. We need specialized microscopes to see these nanoparticles. In early 1986, Binney and Roer, they were working in IBM. They developed scanning tunneling microscope and atomic force microscope for imaging of surfaces at atomic solutions. And this really marked the beginning of realization of nanotechnology as a field. In 1991, Professor Sumio Izuma, he invented carbon nanotubes, which are now used in various kinds of applications like medicine, film industry, coating industry, batteries, and many more. These carbon nanotubes are, the property is they are 100 times robust than steel, and they are used from electronic components to space elevators. They are used in all the applications. Later, in 2013, IBM scientists announced the creation of world's smallest magnetic memory bit. That is made of 12 atoms. This breakthrough actually helped to increase the levels of data storage. In this period, atoms were moved using scanning tunneling microscope, creating world's smallest movie. And this actually entered in. Am I audible? Yeah, actually, this resulted in the formation of world's smallest movie. Now let's watch the world's smallest movie. Are you able to see?
Yes, madam.
Yeah, so this is the world's smallest movie. Here, atoms were moved using scanning tunneling microscopy. Now, what is so special about the nanoscale? You would have learned various properties of materials in bulk form. When it comes to nanoscale, the properties changes like fluorescence property, magnetic property, chemical reactivity. They have their own functions. They change. Here, one example is optical properties. You all know about gold. Gold ornaments you would have seen. That is in bulk form. Now, how do they appear when they are in nanoscale? In nanoscale, when they interact with light, they appear in different color. As you can see here, it changes from different colors like red, orange, green in the presence of light, and it is also possible to prepare these nanoparticles in different morphologies or shapes. And these particular properties, they are put into clinical application. In imaging, this is put into use. Now I have another simple property, that is reactivity. You all know the chemical substance undergoes some change, that is called reactivity. What happens when a glass of water, you take a glass of water and sugar granules. In another glass of water, you take sugar cubes. What difference do you see? Which reacts faster? Sugar granules react faster. Why? Because they have a higher surface area and they dissolve faster. The concept of surface area of nanoparticles is illustrated in this figure. Here you can see a cube sized 1 meter. The surface area of cube is 6a squared. Here the volume remaining same. The surface area is different. So in the first cube, the surface area is 6 meters squared. It is a bulk cube. Then in the second cube, you are dividing the cubes to 8 smaller cubes. There the surface area is 12 meters squared. When you divide a big cube to smaller cubes, the volume remains same, but the surface area increases. Now in the third set, you are dividing a big cube to 64 pieces. Then what happens? The surface area increases to 24 meters squared. So this demonstrates that when the particle size reduces, the surface area increases. The use of nanoparticle was explored from very old times. Actually, people were using nano-based systems from very old days. Here is one example of evidence, that is Lycurgus cup. As you can see in the image, a cup that appears green color and red color in two different lights. In presence of reflected light, the Lycurgus cup appears as green, and in presence of transmitted light, it appears in the form of red-purple color. This is due to metallic properties arising from light. Here in the second image, you can see the glass stained windows of a medieval church. So how this comes? Earlier, the medieval artisans, they add a gold chloride or silver nitrate to the glasses and you get fabulous colors. So actually they were using various chemicals. And 100 years ago, they called it art. And with the advent of science, now we call it as an example of nanotechnology. Examples of nanoparticles are abundant in nature. Here is one simple example. This is a taro leaf of colocasia plant. Otherwise, in Kannada, I think it is called Kesavina Gadde. So this is the leaf of that particular plant, colocasia. Do you see any particular property here? Here you can see a water droplet, right? So they have super hydrophobic nature so that the water droplets roll through the leaves. It cannot stay there. It rolls through the leaf and hence it can maintain clean leaves. They have self-cleaning property. In the magnified image, the image F, you can see the nanostructures that are visible in the leaf. Figure A shows the leaf which we see in our naked eyes, and in figure F, we see the scanning electron microscopic image of magnified nanostructures. This is also same with lotus leaf. You would have also seen lotus leaf, I believe. The same property is there for lotus leaf also. Here you can see the image of butterfly. Do you ever imagine where this color of butterfly originates from? That is from the nanostructures that is present in the lamellae of butterfly. These are complex structures. Here 5000x is a zoomed magnification of butterfly lamellae that is visualized through electron microscope. When the nanostructure interact with light, it produces color, and therefore butterflies have beautiful colors. It is not from any pigment or from any dye. Haven't you noticed lizards climbing on the walls of your home? There is Geco called carnivorous lizard. They climb vertical walls using their nanostructures. Here you can see how the feet of a Geco looks like and how they are imaged in an electron microscope. So this is how their feet looks like. They have nanostructured attachments in their feet that is helpful. The mechanism behind this is adhesive force. This particular mechanism is used or mimicked by industries to produce detach or attach objects like wall hanger. You have a grip and peel device. So here they are used to mimic the detach and attach objects. Now let's get into the overview of nanomaterials. So these nanomaterials exist in a solid form, semi-solid form, and they have nanostructure. They exist in different dimensional sizes. Zero-dimensional materials are which have a point, a zero dot structures. One-dimensional nanotubes have a line structure. Two-dimensional nanostructures, just as they indicate, they exist in the form of sheets or squares. Three-dimensional nanostructures, they have a cubic structure. Here you can see some of the examples. You might have come across periodic table, right? We have metals, non-metals. So all these are fabricated or synthesized into their oxide forms, phosphate forms using various techniques, and results in the formation of nanoparticles. Example could be metal oxide nanoparticles like iron oxide particles. Then you have gold nanoparticles. Then there are carbon-based particles like carbon nanotubes, and also proteins. Now, how are these nanomaterials synthesized? How are they prepared? We can prepare it in lab. There are two approaches for the synthesis of nanoparticles. One is top-down method and second one is bottom-up method. Just like the name indicates, in top-down method, you have a bulk material. You are grinding it or you are powdering into smaller particles and you result in the formation of nanoparticles. In bottom-up approach, you have atoms. You need to combine it to clusters and results in the formation of nanoparticles. So basically, top-down approach meaning from bulk to nanoparticle, and in bottom-up approach meaning small atoms, you result in the formation of nanoparticles. Here you use various techniques like physical, chemical, and biological methods, which is done in lab, either using various chemicals or biological methods. You use various extracts of plants or with the aid of microorganisms, biological substance basically. And in physical method, you use some techniques like ball milling, where you are crushing the samples to powders. You use vapor deposition technique. So we are not getting into detail of each technique. This is for you to understand that particles can be synthesized in lab with various techniques. Now, once the particle is formed, we need to understand or characterize the material, which means we need to understand how the particle is formed. We need to confirm, because we are not seeing through the eye, so we don't know whether the particle is formed or not. So we need to confirm it. How will you confirm? We can confirm by two methods. One is imaging. We say that seeing is believing, right? So we can see the material with high resolution microscopes like transmission electron microscope. The second process is using spectroscopy. There are various spectroscopic techniques available with which we can plot the graph. We get a record of the spectra. So there are two methods for understanding whether particle is formed or not. One is imaging, the second one is spectroscopy. Now let's get into the application. We have seen the basic idea what nanotechnology is, how the properties change, how we can synthesize, and how we can characterize them. Now let's get into the application. Nanotechnology is used in almost all industries. For example, we'll start with consumer electronics. Just like we discussed earlier, from the phone battery to laptops, everything contains chips that are made using nanomaterials. For example, here you can see a recent report by IBM Technologies. They have developed 2 nanometer chip technology, which help to improve the chip performance and energy efficiency. This is now this idea was coined by IBM to improve the data storage and battery life. Another important industry is smart textiles. We have seen fire workers fighting in emergency situation, military personnel, medical workers. All these people need protective garments for working. So at this situation comes the help of smart textiles. Why? Because these fibers have enhanced durability, and it will be useful for the emergency personnel to get protective garment. Another important property is you would have noticed when you wear black clothes, you get stuck with various dust or lint or animal hair. This could be improved by anti-static property. This is realized by using nanofibers. They can repel statically attractive substances like lint or dog hair or dust. So in these situations, you don't need to use a lint roller. You can use a nanofiber with anti-static property. Then comes an important industry, girls out here. You all will be using wide range of products like body lotions, gels, sunscreen, shampoos. So this is realized by nanotechnology. Numerous materials are being used to improve the formulation. Like for sunscreen, there are UV protectors. They use zinc oxide nanoparticles, titanium oxide nanoparticles, and they also have anti-aging creams where they use some fillers or some nutraceutical to improve the performance. Just like in drug delivery, you have a material, you add a carrier, and then you send it to your skin. There the material will be absorbed. There are different formulations like hydrogel formulations. Girls here, have you ever wondered how waterproof kajal works? This is based on a nano formulation. Have you been to Bangalore and have you seen while moving across Bangalore the ongoing metro work? When you go through the metro rail work, have you ever imagined that there are materials which have been used in nanotechnology? So all the civil engineering construction works, the composite materials are made of nanoparticles. From small appliances like sensors to mega structure, the composite materials contain materials that are used to improve the mechanical erosion, thermal properties. Because when you make mega structures, it is very important to improve the durability and mechanical strength. Then comes sports industry. So you all play some or other games and you know the importance of lightweight equipments in sports, right? They help you to elevate your performance. Also, it reduces the chance of injury. Here is one good example. You all know Roger Federer. So in his Wimbledon, you would have also seen Wilson K racket which he uses. But have you ever thought it contains silicon nanoparticles? Yeah, so this has the use of silicon nanoparticles have helped to improve the weight and also to improve the performance. Here is another example where carbon nanotubes have been used by Oscar Pereira in his riding tournament. So these bicycles were made of carbon nanotube to improve the performance and reduce the weight. There are many other components in sports industry which are coming up with innovative product in this particular market. Next comes fuel cells and batteries in automobile industry. So there is very high demand for energy, right? We all know there is very high demand for energy and there is requirement for promotion of renewable energy resources. And there comes the need for energy conversion and storage devices using various nanomaterials. The electrodes they use in battery, fuel cells, solar cells, all these are made of various types of nanofibers. Then comes waste filtration plant. We all know about various filtration process, reverse osmosis process. So in nanofiltration process, which comes between the reverse osmosis stage and ultrafiltration stage. Here they function by both pore size flow and solution diffusion mechanism. This mechanism is used in wastewater treatment plant and desalination of water. Here in desalination process, the minerals of salt water is being removed and this particular water is used for various applications in food, dairy and beverage industries. Another interesting sector is food industry. The applications of nanoparticle in food industry can be summarized into two categories. One is food packaging and the second one is food processing. In food processing, nanoparticles can be used as food additives. You are adding a preservative or these days people use food supplements for improving the nutritional value or vitamin if you have a vitamin deficiency. So such cases, nanoparticle based formulations are added as an additive or a supplement. And also in food processing, if you need to keep the food for a longer duration of time, you need to have a note of antimicrobial property also. So you will add various nano formulations to for food processing. And in packaging, you use various fillers because you need tight packaging with good durability so that your food is not spoiled. Here also you use various types of nanoparticle based material for better quality and safety evaluation. Next comes a medical implant. So if you have visited a dentist, you would have seen dental implants. If you have gone with for root canal treatment, you know, you need to have crown. So these dental implants are commercially available. This actually is practical use of nanoparticle in biomedical industry. These scaffolds, according to the patient requirement, patient-specific implants, dental implants based on calcium phosphate materials are used for dental surgery for restoration of your tooth. Similar way, bone implants are also made. If you have a knee injury or if you met with an accident, there are zirconia-based or calcium phosphate-based implants that are available for bone surgery. Another important advantage is point of care devices. This is one recent development. We all know diabetes is a very common lifestyle disease these days, and we all have one or other a diabetic patient at home also. So you will be knowing that frequent monitoring of blood glucose level is necessary. Earlier, these self-strip glucose was available, where the patient himself will take his blood and then test for the glucose level. But now, with the advent of nanotechnology, wearable glucose sensors are available. Here you can wear it as seen in the figure, just like a patch on your hand, or as a wristwatch, you can wear it. And then this is integrated to an application. Here, your interstitial skin fluid sweat is considered as a body fluid that is being sensed. And then this is integrated to an application and the result is shown in the application. So you can easily monitor it without any blood sampling. So this is one of the very great innovation of nanotechnology. So this is the summary of our talk. We have seen the basics of nanotechnology, its fundamentals and importance in basic sciences like biology, physics, chemistry, and what are its properties. We have seen various properties like optical properties, then reactivity, surface area, and how these properties are put in applications. We have seen almost all the industries where nanotechnology related subjects has been explored. But since this is a research area which needs more exploration, we need to also investigate its environmental and health implications. So now you can read various articles as young students, how these tiny machines can rule the world, what are its future applications, or will it have any health implication or environmental concerns? That is another subject of research. And with this, I'll conclude my talk. I have 2 points to add. Since you are young students out here, I understand this is not the right time for you to start your research, but understand and start studying the fundamental aspects, because for any research application, you need to know the fundamental aspects. So study your undergraduate courses or PUC level courses and understand the basics out of it so that you can explore it to application level during your research time. And the opportunities are lots in this field. You can start looking for various opportunities and understand the ideas of various research options in science, technology, engineering, and medicine. I hope you all might be using Instagram and Facebook. So if you want to know more about various research opportunities, you can follow these two links on Instagram and Facebook. This is a page for researchers by a group of research team. So you can follow them. And now let's move on to questions and answers.
Hello, I am here.
Yes, please.
Yeah, you can ask questions.
Any questions, please feel free to ask.
Sir,
Rugmani madam,
Yes, sir, please tell me.
indeed it was a very scholarly talk, and you gave talk in a very simple language. Students actually they don't know much about nanotechnology. In fact, they must be having only one small chapter related to nanotechnology. You explained
Yes,
it
yes.
so well that many students would have got good information about nanotechnology. Since this
Thank
is
you,
a
thank you, sir.
growing field, I thought nanotechnology to be a good subject for them to learn. That's why we kept this this talk for them to understand something about nanotechnology.
Yes, sir,
And
thank you so much.
your talk was helpful in broadening the knowledge of theirs in this particular talk. Madam, as of now, there are no questions as such.
Okay.
In future, if students pose any questions in email related to nanotechnology, I will just mail it to you. Kindly answer them, madam.
Yes, yes, sir. Please feel free to send questions You can contact Dr. Ramesh for any queries, or you can directly write to me. I'll be able to help you with whatever.
Correct. Madam, please send a few pages of notes. If you have already sent, no problem. Otherwise, 3-4 pages of notes related to nanotechnology basics, so that
Yes,
we'll be
yes.
bringing out a compendium for the benefit of students to refer later.
Okay, sir, I can send it. I'll send it.
Yeah, we are very grateful to you for this scholarly talk and for your time, madam. Yeah,
Thank you very much, sir. Thank you. Thank you for giving me a chance to speak for KSTA webinar.
Yes, madam. Thank you very much.
Thank you very much.
ಸ್ಟೂಡೆಂಟ್ಸ್ ನಾಳೆ ಮತ್ತು ನಾಡಿದ್ದು 2 ದಿವಸ ಟಾಕ್ ಇರೋದಿಲ್ಲ. ಅದ ಮುಂದಿನ ಆಚೆ ನಾಡಿದ್ದಿರುತ್ತೆ. ಅದನ್ನ ನಿಮಗೆ ನಮ್ಮ ಕಲೀಗ್ ಸಿದ್ದೇಗೌಡರು ತಿಳಿಸ್ತಾರೆ. ತಾವೆಲ್ಲ ಅಟೆಂಡ್ ಆಗ್ಬೇಕು ಅಂತ ಈ ಸಂದರ್ಭದಲ್ಲಿ ಕೋರ್ಕೊಳ್ತೇನೆ. 26ನೇ ತಾರೀಕಿದೆ ಟಾಕು. ಅವತ್ತೆಲ್ಲರೂ ಜಾಯ್ನ್ ಆಗ್ಬೇಕು. ಧನ್ಯವಾದಗಳು.
Okay, sir. Thank you, madam.
Friends, sir, thank you. Thank you so much.
I'll end the meeting, madam.